Alright, the other day in class we were talking about the converse, the inverse, the contrapositive. So let's just quickly review this and let's go over it. So this statement says if Yobel has brown eyes, then Ellen has purple hairs. Alright, so let's talk about the converse, the inverse, and the contrapositive. So we have our if-then statement. If Yobel has brown eyes, then Ellen has purple hair. Alright, well, can someone say what the converse is? Alright. And I'm going to go, well, and the converse would be when we switch them. So we switched our hypothesis and conclusion. So if Ellen has purple hair, then Yobel has brown eyes. Would be false if, you can pause it, and then when you guys are ready, just start it back up. Would be false if Ellen has purple hair, but Yobel does not have brown eyes. So that's when it will be false. So the inverse, can anyone say what the inverse is? Once again, just pause it, get some volunteers, and then play it when you're ready. So the inverse, if Yobel does not have brown eyes, then Ellen does not have purple hair. And would be false if Yobel does not have brown eyes, but Ellen does have purple hair. And then the contrapositive, if Ellen does not have purple hair, then Yobel does not have brown eyes. And this would be false if Ellen does not have purple hair, but Yobel does have brown eyes. So remember, the converse is when we switch. We switch the if and the then, the hypothesis and the conclusion. The inverse is when we negate both the hypothesis and conclusion. And the contrapositive is when we switch them. So we switch hypothesis and conclusion and then negate both of them. Now, some conjectures that lead to theorems. Alright, a conjecture is a statement that you think is true, but that may or may not be true. So, some reasoning strategies. We talked about inductive reasoning, which is the process of drawing conclusions based on, yes, patterns. So based on patterns. And we talked about deductive reasoning, which is the process of drawing conclusions based on facts. So you look at the first example, the number of black-footed ferrets has increased each year since 1985. Therefore, there will be more black-footed ferrets next year. That's a pattern. Deductive reasoning is a fact. If Erica did not turn in her homework, then she made a bad grade. Well, Erica did not turn in her homework, therefore she made a bad grade. So which method of reasoning will we most likely use in mathematical proofs? To prove something, we would want to use facts, so we want to use deductive reasoning. So deductive reasoning. So, are vertical angles a conjecture and a theorem? So vertical angles are angles that are opposite each other when lines intersect. Look at a pair of intersecting lines below. Alright? So we can identify a pair of vertical angles, and we can use a protractor. So if somebody at the table wants to get a protractor and measure the angles, we can look at them. So pause it, measure the angles. When everyone had a chance to do that, then we can play it again. And what conjecture can we come to? Well, we can say that angle ABC and angle EBD, they are vertical angles. And we know that because they measure the same, they have the same measure. Alright, so they're opposite of each other. This is angle ABC, this is EBD, opposite of each other, and they have the same measure. So we just came up with the conjecture using inductive reasoning. So now we can use deductive reasoning and prove this conjecture as a theorem. Alright, so the first statement, well, we're given that angle 1 and angle 2 are vertical angles. This is our given statement. So that's what we're given. Then we know that the measure of angle 1 plus the measure of angle 3, so angle 1 plus angle 3 equals 180 degrees. We also know that the measure of angle 2 plus the measure of angle 4 equals 180 degrees. So here's angle 2 and here's angle 4. We can say that this is our linear pair property. They're a linear pair, and we know that linear pairs add up to be 180 degrees. We can say that the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. And I forgot to put the angle symbols in here. And we can say this because of our substitution property. And then finally, we can say that the measure of angle 1 equals the measure of angle 2, or that angle 1 is congruent to angle 2. Because what we are doing, we got rid of angle 3, and we got rid of angle 4. That's our subtraction property. And that's how we come up with our theorem that our vertical angles are congruent. So angle 1 and angle 2 are vertical. Well, their measures are going to be the same. So if we look at the next one, we have our vertical angles. It says to solve these problems algebraically and then find the measure of the 4 angles in the figure below. Alright, so we know that these are vertical angles, so we can say that 7x minus 60 equals 3x plus 20. Vertical angles, so they're equal. Now we can simply solve this. So we do minus 3x minus 3x. So 7x minus 3x is 4x minus 60 is equal to 20. Add 60 to both sides. 4x equals 80. Divide by 4. Divide by 4. X equals 20. So we know that x equals 20, but asks us to find the value of all of the angles. Well, we can plug 20 back in. So this is 3 times 20 plus 20, so 60 plus 20. So we know that this is 80 degrees. And we can check, we can do 7 times 20 minus 60. 140 minus 60 is also 80 degrees. A linear pair adds up to be 180. So 180 minus 80 is 100 degrees. So this is 100 degrees. And this is also 100 degrees. So work on these next couple examples. Make sure that the ones that are vertical angles are equal, and some of them are supplementary. They're a linear pair, so see how you set them up differently. And yes. Alright, so that was our conjecture about the vertical angle theorem.